Hello and welcome to the lecture session on the modified Euler's method, or second part. In the previous video, I have discussed about the modified Euler's method, the details of it, and solved the problems based on that. Now, in this video, I am solving some more problems. Using modified Euler's formula, solve the initial value problem. dy by dx is x plus root y in the range 0 less than or equal to x less than or equals to 0.4 by taking h is equals to 0.2 given that y as 1 and x is equals to 0. Perform 2 iterations at each stage. We need to compute point y of 0.2 first and use this value to compute y of 0.4. So the first stage is consider x naught as 0 and y naught as 1, which is given, and f of xy is the function x plus root y. Therefore, f of x naught comma y naught is 0 plus root 1, which is 1. And x1 is x naught plus h, that is 0.2, which implies h is equals to 0.2. By using the Euler's formula, we have y1 of 0 is y naught plus h into f of x naught y naught. y1 of 0 is 1 plus 0.2 into 1, that is 1.2. Now, by using the modified Euler's formula, we have y1 of 1 as y naught plus h by 2 into f of x naught comma y naught plus f of x1 comma y1 of 0, where y1 of 0 is obtained in the Euler's method. So, 1 plus 0.2 by 2 into 1 plus 0.2 plus 1.2 under the root, which on simplification gives us 1.23. Next, y1 of 2 is given by y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of 1, which gives us 1 plus 0.2 by 2 into 1 plus 0.2 plus root of 1.23, which is obtained in the first stage, first value. That on simplification, again we are getting 1.23. This is the problem what we have obtained. Now, the second stage, x naught is 0.2 and y naught is 1.23. Now just you can see the question, how it has to be done. It is by using 0.2 as the step value, we need to compute up to 0.4, that is y of 0.4. So x naught is 0.2 and y naught is 1.23. So f of xy is x plus root y and f of x naught y naught is 0.2 plus root of 1.23, that gives us 1.30. And x1 is x naught plus h, which is 0.4 with h as 0.2. Now, by using the Euler's formula, we have y1 of 0 as y naught plus h into f of x naught y naught, that is 1 plus 0.2 into 1.30, that gives us 1.26. Now, by modified Euler's formula, we have y1 of 1 is y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of 0, which gives 1.23 plus 0.2 by 2 into 1.30 plus 0.4 plus root of 1.26, which is 1.512. Next, this value is used in the place of y1 of 1. That is, the formula is given by y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 of 1. So on simplification, that is y of 1.23 plus 0.2 by 2 of 1.3 plus 0.4 plus 1.512 under the root, which is on simplification we get 1.52. So this is the answer we are getting for y of 0.4. This is the answer of the second stage. Okay, so which has been completed in two stages now. In the first stage we have computed y of 0.2. In the second stage we have computed what is y of 0.4. Next problem. Using the modified Euler's method, solve the initial value problem dy by dx as log of x plus y, where the initial condition is given by y of 1 is 2 at x is equals to 1.2 and 1.4 by taking h is equals to 0.2. We need to compute y of 1.2 first and use this value to compute y of 1.4. So in the first stage, consider x naught as 1 and y naught as 2, which is given here. And f of xy as log of 1x plus y. Therefore, f of x naught y naught is given by log of 1 plus 2, which is log 3. So we are getting 1.03. Now x1 is x naught plus h, that is 1.2, which implies h is equals to 0.2. By the Euler's formula we have y1 of 0 is y naught plus h into f of x naught y naught, that is 1 plus 0.2 into 1.09, that is 1.218. Next, by using the modified Euler's formula, y1 of 1 is given by y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 0. And we have computed y1 of 0 already, so that will be substituted. So y naught is 2 and h is 0.2, so 0.2 by 2 into f of x naught y naught is 1.09 plus log of 1.2 plus 1.218, which is computed previously. This on simplification we get 2.197. So y1 of 2 again is given by y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 1. This y1 of 1 is obtained here in the first step. So 2 plus 0.2 by 2 into 1.09 log of 1.2 plus 2.197, which gives us 2.231. This is the first stage answer. Now the second stage. Coming to the second stage, consider x naught as 1.2 and y naught as 2.231. And f of xy is log of x plus y, that is log of 1.2 plus 2.231, which gives us 1.233. And x1 is x naught plus h, which gives us 1.4. H is 0.2. So by using the Euler's formula, y1 of 0 is given by y naught plus h f of x naught y naught, that is the y naught is 2.231 plus h is 0.2 and f of x naught y naught we have obtained is 1.233. On simplification we are getting 2.477. Now by modified Euler's formula we have y1 of 1 is y naught plus h by 2 f of x naught y naught plus f of x1 y1 of 0, that is 2.231 plus 0.2 by 2 into 1.233 plus log 1.4 plus 2.477. This on simplification we get 2.4898. Next, let us go for the next iteration, that is y1 of 2. It is given by y0 plus h by 2 f of x0 comma y0 plus f of x1 y1 of 1. That is 2.231 plus 0.2 by 2 of 1.233 plus log of 1.4 plus 2.4898, which gives us 2.490. Therefore, y of 1.4 is 2.490. This is the answer we are getting at the end of the second stage. So, I have solved with the stage 1 problem as well as stage 2 problem. Thank you.